Hi, welcome to this tutorial of question number 4 of F324 Jan 2010 paper. In question 4 we've been given 6 compounds, out of which we've got 3 esters and 2 carboxylic acids. The question says that the chemists use both infrared and carbon-13 NMR to identify the 2 carboxylic acids and to distinguish between them. And it says, how do both types of spectra allow the carboxylic acid to be identified and distinguished? So the first part is, how would they be identified? They would be identified by using infrared spectroscopy. As we know, infrared spectroscopy tells us which functional group is present in a compound. So it's asking about carboxylic acids, and if you refer it to the data sheet, you should see that the carboxylic acids have a absorption peak at 2,400 to 3,300. So the esters would be esters would have an absorption between 2,500 to 3,300 centimeter. Minus 1. Now it's we'll come to the second part, in which we have to tell how we differentiate between the 2 carboxylic acids. Now we've got 2 carboxylic acids. I prefer the best way to do this question would be, this part would be drawing out these structures. So we've got this ester. I'll see on the back. Okay, we've got one carboxylic acid, which is CH3, and CH3. It's just got another CH3, and that is attached to carbon. Another carbon OH. We've got a second carboxylic acid. It's got CH3, hydrogen, carbon, and then another carbon, the carboxylic group. Now, the carbon-13 NMR tells us how many different carbon environments are present in any compound or sample. So we'll just work out how many peaks would this compound give, and how many peaks would this compound give in a carbon-13 NMR. So here we've got methyl attached to carbon, another methyl attached to carbon, another methyl attached to carbon. So these all would be same carbon environment. Then we've got another carbon which is attached to the carboxylic group, and 3 methyls. That's our second carbon environment. Then we've got the carbon of the carboxylic group. So this compound would have 3 environments. And if you have a look at the second compound, we've got methyl attached to carbon, methyl attached to carbon. That's these have same carbon environment. Then we've got another carbon attached to hydrogen. That's second environment. We've got another carbon attached to 2 hydrogens. That's our third environment. And then we've got the carbon of the carboxylic group. So it's got four different environments. So the answer would be, this compound will have 3 peaks on carbon-13 NMR, and this compound would have 4.